Okay, question 7a first, and then we'll move on to B. So, you're given some information in the table, and I've instantly gone to work out what delta T is, and what the mass of the fuel is used. And I've just made a note of those two myself. So the question asks, use the results to calculate the heat energy released from the combustion of this sample, specific heat capacity of water. Right, I'm seeing specific heat capacity, right, I'm working out Q. So we've got the mass here. That's going to be the mass of the water, because that's what you've heated. Quite a few people use the mass of the fuel there. Specific heat capacity we're given, that's going to be 4.18, and our change in temperature we've worked out is going to be 27.3. So if we input all the numbers, we've got 50 times 4.18 times 27.3. That gives us an answer of 5,705.7 joules of energy. Remember, it's joules. Right, then we move on to part B. Part B asked, calculate the amount in moles of 2-methyl propan 2-ol burned in the experiment. Hence calculate a value in kilojoules per mole for the enthalpy of combustion. So we need to work out the number of moles. So we're going to do moles equals mass divided by mR. So I'm going to use that number I calculated previously of 0.22 divided by the mR, which is 74, and that gives me moles of 0.00297 moles of fuel used. So I have a delta H. I've calculated Q already, so I know that I have 5,705 joules of energy. Now they've asked it to be in kilojoules, so I'm going to convert it at this stage. So delta H per mole is going to be 5.705, so that's in kilojoules. Previously we had the answer in joules. I'm going to divide that by the number of moles I've got, and that gives me 1920.87 kilojoules per mole. Now, I've burnt a fuel here. This is an exothermic reaction, so I need to put that minus sign there, otherwise I'm going to lose the marks.